Uh, Good afternoon, all. Welcome to another TechBrew session from Altair. Topic for this session is going to be uh, ML-based predictive and prescriptive studies using RapidMiner platform. Right. So, just few housekeeping rules before we start. If you have any questions during the session, you feel free to post in the chat window. And also, we do have surprises for the good questions out there, right? So there will be Amazon vouchers also, right? So I think we can get started. So for this particular session, uh, uh, we are going to talk about uh, RapidMiner, which is Altair's data analytics and AI platform, and its application in product engineering, right? So from Altair, we do have a couple of offerings uh, catering to AI in product development. So we already covered Design Explorer and Physics AI in our earlier session. So these platforms, basically AI is augmented within our traditional HyperWorks suite of products, which you can use within natively within HyperWorks products. But what we are going to focus today more is the RapidMiner platform from Voltaire, which is a generic data science platform where which is data agnostic. You can bring down data from simulations, testing, sensor data, right? And you can start building your models and get the predictions done. And on top of that, this tool is a low code, no code tool, again meant for engineers like us who, without any coding know how, they can start using this platform and start building their machine learning models on their engineering data, right? So let's get started. So from CE perspective, from product engineering perspective, uh, the data what we have uh, may come from different sources. The simulation data what we have. So it could be data that is historical simulations what we have, right? Or it could be DOE studies what we do, or data that is coming from the testing and in service, equipments and operational products, right? So the data what we are getting, we need to basically transform the data, and the data should be in a structured form. Like if you have simulation data, what you can do is if it's DOE data, that can be directly used. The complete run matrix can be used, or if we have historical simulation data, then can be transformed, or we need to do some feature extractions, and we have to convert into some sort of structure form, like rows and column form, which will be used to build these models, right? And you can basically get this data into RapidMiner and start building your models without any, again, any coding know-how, with just drag and drop functionality or auto machine learning. And once these models are built, validated, you can use these models for doing your predictions. So generally the computations what you do with simulations. So similarly, we can predict those responses using these machine learning models, right? And even you can build certain prescriptive analytics layer as well over it, and you can do some optimizations as well using the same machine learning models. Uh, so let's pick one use case here, and what I'll do is I'll demo that use case for you in RapidMiner. And let's pick maybe a electric motor use case. So here we have done a lot of simulations, say already. So using one of the Altair tool Flux, which is used for electromagnetic simulations for motor, and using Hyper Study from Altair, which is a DOE study and optimization tool. So we have set up a DOE study here in Hyper Study, and using the parametric design studies. So we have basically uh, created a lot of design variables specific to the shape of the stator geometry, and we have carried out this DOE study. And with this DOE study, what we have kept done is we have generated a lot of data in terms of the simulations runs what we have done, And the design variables that were there in this study was specific to the shape of the stator. So what you can see here, like slot depth, slot opening angle, opening depth, stator tooth width, right? So these sort of variables. And then the responses which were coming out of the simulations were like the torque, right? Max current density and all, right? So now once this data, the complete run matrix of DOE is there with us, what we are going to do is we are going to use RapidMiner to build these machine learning models here, right? With RapidMiner, a user can work in two ways. Either he can use a visual workflow way, which is more of a drag and drop workflow based functionalities with ready to use operators. He can basically build his workflow and start building his model and testing them, right? And there is another uh, say way he can use, that is auto machine learning. So with just few clicks he can just build his models, right? So we'll see both approaches here. Now, giving you a little context here, because what we are going to do here is we are trying to formulate one of our engineering problem in a data science workflow. And we are very familiar with the CA workflow, which is on the right, if you see, where we basically start with understanding our problem, do pre-processing, then solve it. We pick the right solver scheme, and once the solving is done, we obviously do post-processing, and based on those insights, what we get, we obviously go for design improvement, right? So similarly, data science also have similar sort of workflow, and what we call this standard workflow is CRISP-DM, that is a standard process for data mining. And here also again we do the same. Uh, you start with again the problem understanding that you have, or the use case understanding. So basically in this case we have this e-motor use case. We have certain design variable. If we vary them, the response is going to vary, right? So we have carried out a lot of simulations, and with that we have generated a lot amount of data with us, right? So basically first part is understanding that data, what kind of data it is, what kind of relation these variables have with the responses what we are trying to predict, right? So all those sort of data understanding we'll do. With that, what we'll do is we'll try out different machine learning models. So the advantage of RapidMiner here is you get a comprehensive list of machine learning models that are available. You can try out different machine learning model and see which is best uh, catering to your specific use case, and giving you the best prediction accuracies, right? You can do a comparison of different models, and based on that basically you can also evaluate the performance, how the model's predictions are going, right? And once you are satisfied with the model validation part, then obviously you can use those models for doing your predictions, right? So this is the workflow which we are going to basically focus and see in the live demo, right? So let's move to the demo part now. Uh, Let me show you a RapidMiner. So this is the interface of RapidMiner. Once you start RapidMiner, in the center you see the blank area. This is your canvas where you can build your workflow. You have your repository here where you can import your data, store your models, and the most important part here is this, the operators. So you have these ready to use operators that are available for you. So you can just drag and drop these operators and build your workflow. So this is what is the design view of RapidMiner. Uh, Again, you do have basically auto modeling functionality as well, which I mentioned. I'll also explain this part. So we'll touch upon both design workflow and auto model, right? So let's start uh, with the workflow here. So what I'm going to do is, first of all, you can import the data what you have, right? So you can import the data from your system, whatever the DOE generated data you have. So already say I have imported this particular data here, and what I'm going to use is I'm going to import this data, and let's see. So you can, this data is already stored with me. I'm just dragging and dropping this data. So first of all, I can say, I can just connect this data to my output port and just hit this play button. And this way I can see what is there in that Excel file or what data I have. So I have these variables which are design variables like slot depth, slot opening, opening depth. So all the shape variable of the stator. And then I have this torque mean, induction, current density. These are my responses, right? So this view I'll get. Obviously, I can see some of the basic statistics of the data, that each of these variable, what is the mean, max, uh, what is the range in which they are lying. So obviously, I can see the scale is little different. The current density here is, it at a higher scale. Obviously, there are some visualizations as well which I can create to understand my data. So let's say if I create a visualization where I want to see, okay, torque mean, how basically it is varying with the my stator opening depth, right? So if I see here, uh, if I increase my opening depth, the torque mean, mean torque is basically increasing, right? Similarly, if I say a relation of torque mean with say slot depth here, right? So here also, if I see with the increase in the slot depth, the torque mean torque is basically decreasing. So that way you can start understanding your data, right? What kind of relation these variables are having, right? Um, so after this, what I'm going to do is say, you we can basically select what all variables you want to include in your study, right? So we have something called as select attributes here. So you can just search here the operator and just drag and drop that operator. So select attribute is the operator here. I want to see, okay, uh, I want to exclude some of the columns here from my Excel file, from my data. So I'll say, let's see what all I should exclude here. So what I want to include in my study is just these design variable of the stator, and maybe the torque mean which I want to predict. So maybe these other responses and the variables I will just exclude from my study. So I just want to build a machine learning model to predict mean torque if I change these design variables, right? So I'll say apply, and let's again say study. If the data is filtered now, I have torque mean and these variables, right? Uh, now let's go and add another operator. So good part with RapidMiner is it will recommend as well. So in the bottom, if you see, it is recommending which next operator you should use. So the set role is the next operator I can use. Set role means what you want to predict. You have to basically set that. So I'll say I want to predict torque mean. So I want a machine learning model to get trained on this data so that next time onwards it should predict the mean torque for me, and considering if I give the new design variables, the new stator shapes to it, right? So I've set the role here. Then the next step is what we can do is we have to split this data. So the data what we had is around 104 rows of data what we had. So we are not going to use the full data for training my model. I'm going to split this data into training and testing. So let's split this data, right? So let me say I want to use 90% of the data for training and maybe 10% of the data for validating my machine learning model, right? So that 10% of the data will remain unseen to this model during the training phase, and once the training is done I can validate with this, right? So if I run this as well and I show you, so you can see basically I have split the data. Now 10 example rows are in this uh, uh, split, and another say 94 in the other split. Otherwise total was 104, right? So now once this data split is done, now basically what you can do is you can try out different machine learning models here, right? So here there are almost 160 plus machine learning models available within RapidMiner. all different type of supervised, unsupervised uh, regression, classification, deep learning models are there. So let's start with a basic one. So let me uh, uh, say import a linear regression model here. So this is my linear regression model, and now what I can do is uh, I want to apply this model, right? So let's say apply the model here, right? And so one is like the first split that was there on which the model is going to train, right? And obviously I have to validate this model as well, right? So on the unseen data, that's what I'm going to do. And I can basically do is I can check the performance as well here. So I have a performance operator as well, which I can just import, and I can see how my model is performing, right? So this is performance, and what all performance attribute you want to see of this prediction, like say root mean square, absolute error, relative error, maybe how accurately it is predicting, squared error and correlation. So these all attributes I can basically select here. Then maybe I want to store the data as well, store the predictions which are happening. So I can bring down a store operator as well here. So which will save the results for me, right? So what I can do is I can store the data, right? And now I can connect this to the output port, right? And then basically I can carry out my study. I can play this and see. So obviously store where you are going to store, that also path I can give. So I want to store in this folder. So I can copy this path here and maybe give a name to the file as well. Say store results, and then basically I can run this. So now you can see the model have run, and what it is showing is on your validation data, this was the actual torque, mean torque, and this is what's predicted by the machine learning model, right? So next time if you give these shape variables, these design variables to this machine learning model, it can predict the torque for you, right? Obviously I can see the performance, how accurately it is predicting. So correlation is pretty nice, and even the error is pretty low for this model, right? Even I want to see certain plots, so I can see how my torque, actual torque versus predicted, how they're meeting. So I can see they are in a nice agreement. So the green one is the predicted torque, and the blue one was the actual torque, right? So this way I can see my models are pretty good, right? So this is like how quickly you can set up a workflow. So obviously there is a linear regression model here, but you can try out lot more other models as well, right? Now even what I can do is I can use auto machine learning as well here. Or before that, what we can do is I have already set up a process here, and let me just put up this process and run it. Also, what it will show you is you can see a correlation matrix as well. How your variables are correlated with each other, right? Or even what I can do is I can see for torque uh, response, which particular variable have the maximum influence. So in this case, load depth have the maximum influence on my torque, right? So this is what I can see here, right? Now this was one way. What I can do is now I can go on the uh, auto model way as well. So this is I can go to the auto model tab. So this is where auto machine learning can come handy, right? So here also you can just import your data. So in this way, I've already imported the data. So this is again the same data what we have, right? These are the design variable and these are the responses. So I want to build. So you have to just do these 5-6 clicks, and you end up building a machine learning model, right? So I'll say predict. So it will ask what you want to predict. I want to predict this torque mean here. Next, it will show the distribution of the torque mean torque in your data. Then based on your domain understanding and the recommendation given by the tool itself, you can see which all variable you want to take in your study. So obviously slope depth I want to keep, stator tooth width as well. torque max is a response which I'll drop. These are not design variables, right? Even the torque mean as well, and this as well. So I'll include these 5 variables into my study. Say next. So it will run all these machine learning models automatically, right? It will optimize these machine learning models as well. You can even select automatic feature selection or automatic feature generation as well, which also it can create some new features or design variables as well. I'll just say run here, and so it will run these machine learning models uh, parallelly, and it will give you a comparison matrix as well. So which model is working and what kind of relative error, or correlation you are having with these machine learning models. So some models can run quickly. Some of the advanced models they may take some more time. So once this is done, so it is showing that support vector machine is the best model what you have here, right? Obviously, you can see the correlation and all those things, right? That I can do is I go to support vector machine model, and it will show you the weights as well, like which particular uh, more variable have a more influence on your uh, torque, right? And the good part is it will show you this sort of a simulator as well, which an engineer can use it for predictions, for his trade-off studies, what if studies. So what you see here is torque, right? And maybe I can change these variables, right? I can change these variables and see how my torque is changing. Right? I can play with these variables and I can see how my torque is changing. Right? And on top of this, what I can do is I can do this is predictions. I can do optimization as well based on this ML model. So there is an optimized model here, optimize option. So what I can go is maybe I want to achieve a target of say uh, 0.1 87 of set torque, right? And maybe you can put some constraint as well here, like you want say opening depth to be constant to say 0.48, right? And that constant you can add, and then you can run this say optimization, right? And it will basically suggest you what other design variable you should have to achieve this particular target what you have set. So this is more of a prescriptive study what you have here, right? So this is just a quick uh, demo. I just wanted to show you for both the workflow here, right? Uh, Now what I'll do is uh, will what you have seen is uh, this design workflow way and the auto model way as well, right? So an analyst, a designer, they can use this sort of a simulator environment on his desktop, and they can do these predictions and prescription. That is one part. Now, suppose you want this prediction to be used by other users also within your organization, right? Which may not, the users may not have access to RapidMiner, right? So there is a way where these models can be deployed and can be exposed or can be given to other users as well. So we have a deployment environment as well where we can deploy these models, and then the other users who are given access to it, they can just simply open it in browser and just get their predictions done, right? So similarly here what we have done is where we have designed basically a dashboard using one of our Altair tool, that is panopticon. So what you see here is just a user can open once this deployment is done in their organization environment. So this link is only can be shared with the users. They can open the link, and this sort of a dashboard, this is again a custom dashboard which can be basically designed on Altair panopticon, right? And here this sort of a calculator sort of a utility, these designers or users they can use. They can basically say change these design variables, and they can say okay predict, and I can get my the torque predicted here, right? And again the whatever the predictions are done, even I can basically export this as a Excel file or a CSV file as well here, right? Which basically if you want to use uh, anywhere or you want to just make it a report, So you can basically have that as well, right? So this way you can have this sort of a utility also developed, which can be used by other users as well, right? So I like to stop here, and we can have the questions now. If you have any questions, you can post in the chat window, and we'll be answering the questions. Before that, let me just share one more. This is one of the applications which we have discussed, but obviously there could be uh, many more applications where our customers have worked and used RapidMiner for. So just to give you a very high level snapshot of some of the adoptions and applications. So people have used for building certain applications for predicting the simulation results for certain impact scenarios, pedestrian impact scenarios, certain use cases coming from fit, be it the data coming from CAE test or in-service data, where they are predicting certain performances, virtual sensor development, or predicting certain anomalies. Uh, some of our customers, they are using for material analytics as well. So predicting the material properties based on the training a model, machine learning model on historical material testing data. Then uh, the data may come from actual in-service vehicles as well, or systems as well. So that is where, say, suppose you have a lot of vehicles running, EV vehicles running, uh, uh, which are generating a lot of data, say, for their battery systems, and you want to build a model to predict how the battery life is degrading, right? So those sort of a models is what you want to build. Or it can come down to just warranty sort of cases where the data can come from various sources, and just you want to identify the root cause of those warranty issues. So these are just various areas, just to give you a, a high level snapshot of the application areas. There could be many much more application areas. Feel free to connect with us if you have a relevant use case or you want to work with us. We'll be happy to work with you.